Hello, you guys. Welcome to today's lesson on linear equations. Before we get started, make sure you have a piece of paper out and something to write with, or even better than that, if you can go into the course and then course content and then unit 3 and then linear equations, there is a note guide that you can print out that you can complete as you follow along with this video. Listed here you will see the vocabulary that we are going to be talking about during this lesson: line, linear equation, and standard form. At any time in the video you need to slow it down or pause it or restart it. Go ahead and do that. So go ahead and push pause and write these vocabulary words down, and then push play when you're ready to move forward. Unit 3 is on linear relationships, and we are going to spend today talking about lines. And this right here provides the definition of a line. And there are lots of things that we need to know about lines. Make sure you have all of these written in your notes. We're not going to be talking about all of them today, but we will be talking about them throughout this unit. A line is straight. It has no curves. A line extends forever in both directions. So you can see these arrows here, this arrow and this arrow, and this arrow and this arrow. That means that these lines extend infinitely, which means that a line is made up of an infinite amount of points. If the line goes on forever and ever and ever, that means that the number of points that we could plot on the line goes on forever and ever and ever also. In order to graph a line, we need to know at least 2 points the line passes through. Every line has a specific equation, and the ordered pair for each point on the line satisfies the equation of the line. We are going to spend most of today's lesson talking about this one right here, that every line has a specific equation. So let's go ahead and take a look at what equations of lines look like. You can see here that this shows the linear equation is an equation that when graphed is a line. Okay, so we talked about ordered pairs a couple of lessons ago, and we know that an ordered pair provides an address for a point. Okay, it provides its location for us. A linear equation is like that in a way. It provides a way for us to identify a line. And each of these here are examples of what linear equations look like. Right here we have some non-examples. So I want you to take a look at these examples and these non-examples, why I graph each of these lines for you so that you can see what they look like. This line x equals 2. This is a line that crosses through 2 on the x-axis. You can see that the line x equals 2 is a vertical line. Let's go ahead and look at the next one. Y equals 2x plus 3. So this line crosses through the y-axis at 3, and its slope is up to the right 1. Okay, so this is the line y equals 2x plus 3. And you can see that this line slants up and to the right. The next one, y equals negative 4. This line crosses through negative 4 on the y-axis. 1, 2, 3, 4. And it is a horizontal line. And then the last one, negative 3x plus 2y equals 6. It's going to cross through the y-axis at 3 as well. Okay, so this last one, negative 3x plus 2y equals 6, we can see that it also slants up and to the right. Okay, so that is how all of these equations graph a line. Now, when we look at these examples, what do you see? And when we look at these non-examples, what do you see? We can see that a linear equation can have just an x, or it can have just a y, or it can have both an x and a y. Okay, so that's one thing that we need to realize about linear equations is they can have just one variable, or they can have two variables. Now, when you look at these variables, can you see that none of these variables have been raised to a power higher than 1? This is just an x. It's not an x to the second, or an x to the third, or an x to the fourth. Okay, each of these variables are just x or y to the power of 1. Now let's go ahead and look at our non-examples. Okay, when we look at this one right here, can you see that this is y to the power of 2? This has been raised to the second power. That's what makes this not a linear equation. Any equation that has a variable raised to a power higher than 1 would not be a linear equation. When we look at this equation right here, can you see that you have a variable in the denominator of the fraction? This x is in the denominator of the fraction. That is what makes this equation not a linear equation. In order to be a linear equation, all of the variables have to be in the numerator of the fraction. Okay, when we look at the next one, 3x to the second power minus 5x plus 6, we can see that this power is 2. So the x has been raised to the power of 2. So that means this is not a linear equation. And then the last one, 2 times x plus 4. The reason that this is not a linear equation is because it's not even an equation. It doesn't have an equal sign. This is just an expression. Okay, so in your notes, you need to have the rules that linear equations follow. So linear equation has one or two variables. No variable in a linear equation is raised to a power greater than 1 or used as the denominator of a fraction. Okay, so a variable can't be in the denominator of a fraction, and it can't be raised to a power higher than 1. For this next part of our video, we are going to determine if each of these will graph a line, and I can see that this slide did not show up that great in my recording. So for the first one, x equals 3. We are just deciding whether it will graph a line or not. So let's go back to our rules. So does it have one or two variables? Yes, it does. Is the variable raised to a power greater than 1? Nope. Is the variable used as a denominator of fraction? Nope. So we would say yes, x equals 3 is a linear equation. So the next one says, and I'll just go ahead and type this in for you, sorry about that, y equals negative 2x plus 3. We have to decide if this is a linear equation. Well, we have a variable x that's raised to a power of 1. There's no variable in the denominator of a fraction. It has two variables, and we know that linear equations can have one or two variables, so we would say yes, this is a linear equation. The next one, we have y squared minus 4 equals 6. This one is not a linear equation. Because this power is a power of 2, then we would say no, it's not a linear equation. Linear equations have to have variables raised to only the first power. Let's do the next one. 1 over x minus y plus 3 equals 4.
to decide if this is a linear equation or not, we would say no, because in this one there's an x in the denominator of a fraction. For the next one, y equals negative 6. This one is yes. It has one variable y, but the y has not been raised to a power higher than 1, and it's not in the denominator of a fraction. The next one says negative 3x plus 4y equals 12, and we would say yes, this is a linear equation. It has two variables, neither of which are raised to a power higher than 1, and there are no variables in the denominator. Let's look at the next two. 3x to the second power minus 7x plus 8. We would say no, this is not a linear equation because this has been raised to the power of 2. And for the last one, 5x plus 4. This is not a linear equation because it doesn't even have an equal sign, and equations have to have equal signs. Okay, so for this class, there are a few different forms of linear equations that we're going to be talking about. And that a form just means that we can manipulate the equation to be in a certain order so that we can use it for whatever purpose we need to use it for. This form right here, standard form, is a form that every linear equation can be written in. So if it's in a linear equation, it can be written in standard form. And if an equation can't be written in standard form, then we know it's not a linear equation. When we look at an equation in standard form, we have the x term and the y term on the left side of the equation. And we have the term that's just a variable on the right side. Okay, so when we look at equations that are in standard form, we have the x term and the y term on the left side, and the term that's just a constant, so that means the term that's just a number, that is on the right side. Each of these below is an example of equations that have been written in standard form. So you can see that the x term and the y term are on the left side, and the term that's just a number is on the right side. Okay, so each of these equations has been written in standard form. The a, the b, and the c, so when we look at the a, the b, and the c, the a and the b are just the coefficients of the term. And remember, way back in the beginning of the year, we talked about coefficients. And the coefficients are just the number part of the term. And whatever sign is in front of the term, that is the sign of the coefficient. So let's go ahead and look at these examples here and identify the coefficients. So when we look at this example, 2x plus 4y equals 8, the coefficient of the x term is 2. The coefficient of the y term is 4. And because there's a plus sign in front of it, that makes the coefficient a positive 4. So the a would equal 2 and the b would equal positive 4. Let's look at the next one. We have a 5 and we also have a negative 7. So the a would be 5 and the b is a negative 7. If we look at the next one, the a is 3 and the b is negative 9. Okay, and then our constants we can see are on the right side of our equation. So we are going to spend the rest of our lesson taking an equation, a linear equation, and writing it in standard form. So we're going to be manipulating the equation so that it's in standard form, and then we are going to identify the values for A, B, and C. Okay, this is what you're going to need to be able to do for your quiz. So we're going to do a bunch of these together, and then you will have 3 that you need to do on your own for your quiz for this lesson. The ones that you are going to do on your own are number 3, number 6, and number 7, and we will do the rest of them together. So number 1, y plus 2 equals negative 5x. Okay, now we need to write this equation in standard form. So remember, standard form is where we have the x term and then we have the y term equal to the term that's just a number. So let's go ahead and look at this question number 1. Okay, as we look at question number 1, we have the y term on the left side of our equation. We have the constant on the left side of our equation, and we have the x term on the right side of our equation. In order to be in standard form, this term's going to have to be on the right side, and this term's going to have to be on the left side. Okay, because remember, in order to be in standard form, you have to have the x term and the y term on the left side, and the term that's just a constant on the right side. So the way that we move the 2 to the other side of the equation is by subtracting 2. And whatever we do on one side of the equation, we have to do the same thing on the other side. So that is going to leave us with y is equal to negative 5x minus 2. Now from there, we just need to move this equation this term right here to the left side of the equation. So we're going to do that by adding 5x to both sides. Okay, so as we're manipulating these equations, we're basically just using opposite operations to help us to get the terms where we need them to go. Now, this equation, 5x plus y equals negative 2, is in standard form. We can see the a is 5. We can see the b is just a 1. And the c is a negative 2. So let's go ahead and look at number 2. Number 2 says negative 9 equals negative 4x minus 7y. Okay, so in order for this equation to be in standard form, we need to have the x term and the y term on the left side equal to the number term on the right side. One other thing I want to mention when it comes to standard form is there can't be any fraction coefficients. In order for an equation to be in standard form, there can't be any fraction coefficients. Okay, and we're not going to deal with any for this lesson where there are fraction coefficients, but as we move forward, we will be doing that. Okay, so that's just something that I want to make sure that I mention. So I want you to look at something really quickly before we start this one. If I have an equation that looks like this, 5 equals x plus 2, I can rewrite this equation as x plus 2 equals 5, and it doesn't change anything. It's still the same equation. Or if I have the equation 2x plus 6 equals y, I could rewrite this as y equals 2x plus 6. So as we are looking at question number 2, if we want to move things around so that this equation is in standard form, we can just rewrite this equation. So this is on the left side and this is on the right side. Now I didn't change anything else. I just rewrote it. Okay, negative 4x minus 7y is still equal to negative 9. But now this equation is in standard form. We have the x term with a coefficient of negative 4. We have the y term with a coefficient of negative 7. And we have our constant term, which is negative 9. So let's go ahead and look at number 4. Number 4 says 3x equals 8 minus 6y. Okay, so let's look at this equation. We've got ax plus by equals c. That's our standard form. And we want to get this equation in standard form. So we've got the x term where it needs to be. It's on the left side of our equation. We have the constant term where it needs to be. It's on the right side of our equation. But we need to move this negative 6y to the other side of the equation. So we're going to do that by using the opposite operation of addition. And if we add 6y to the right side, we have to add 6y to the left side, which gives us 3x plus 6y equals 8. This equation is now in standard form. Our a is 3. Our b is a positive 6. And our c is 8. Okay, so let's do number 5 together and then number 8 together, and then you guys will be ready for your quiz. Okay, so on number 5, we have negative 5 equals 6y plus x. Let's go ahead and just rewrite this as 6y plus x equals negative 5. Remember our standard form, ax plus by equals c. When we look at this, we're pretty close. Let me show you something else. If I have 5 plus 4, that is the same thing as having 4 plus 5. I can rearrange these terms and it still gives us the same answer, right? Or if I have 10 plus 6, that's the same thing as 6 plus 10. So let's go ahead and apply that principle here. We have 6y plus x, but we could just rearrange this and write it as x plus 6y equals negative 5. And now this equation is in standard form. The coefficient of our x term is 1. The coefficient of our y term is a positive 6. And the coefficient, or the constant, sorry, is negative 5. Okay, the last one we are going to do together, number 8. We have negative 7 equals negative 2y minus x. Negative 7 equals negative 2y minus x. So in order to write this in standard form, let's just first rewrite this. We rearrange the way this equation is written. So let's move this whole side to the left side, and let's move this side to the right side. So negative 2y minus x equals negative 7. And then this is almost in standard form. All we have to do is rearrange the way we write these. When you rearrange these, make sure that you take the sign that's in front of the term with it. So we need to rewrite this as negative x minus 2y equals negative 7. Notice how there's a minus sign in front of the x. So when I rearrange the order that we were adding in, I made sure to keep that sign in front of the x. And then there's a negative sign in front of the 2y. So we have to also keep that sign. So the coefficient of the x term is a negative 1. The coefficient of the y term is a negative 2. And the constant in this case is negative 7. And voila! You guys now know how to write an equation in standard form. Okay, so it is quiz time. Now, on your quiz, I need you guys to do a really good job of identifying where your quiz is for me in your notes, okay? So please write quiz and then write these 3 questions down. You're doing number 3, number 6, and number 7 on your own. Remember, you are putting these equations in standard form, and then you are identifying the A, the B, and the C. Okay, so number 3, 8y plus 5 equals 5x. Number 6, 2x plus 6 equals 8y. And number 7, negative 4y minus 8x equals negative 4. You guys, I want you to know that this lesson is really quite tricky, and you may need some extra practice with Miss Kohler or I in order to be able to manipulate these equations. Okay, so if you need some extra practice, if you're not quite sure how to do this, please come to class. Class is every day from 9 to 10:30. Or you could also join us in the math lab, which is Tuesday, Wednesday, Thursday from 3 to 5. And if neither of those times work for you, you can email us, you can call us, you can ask us to set up another time that will work. We really want you to be successful with this. And like I said, it may be something that you need extra help with. If not, go ahead and do your quiz, get it turned in the box, and you will be done with this lesson. Have a great day.